Okay, hello, I am one. I'm just going to show you a little bit of a review of what you learned yesterday for exponential functions, and I'll show how that applies to what you're going to be working on today. So you're on section 8.1.2, and so just as a review, exponential functions are in the form of y equals a times b to the x power. A is the starting value. B is what's referred to as a ratio, or how it's changing from one number to the next in the sequence. So doubling, in other words, would be times 2 each time, and cutting it in half would be times 0.5 each time, and so on. And then x is the exponential variable. Okay, so we'll show how that applies to number 21. So here on 21, you have the scenario of a ball bouncing, and what you can see is that this is decreasing, and the question is it decreasing exponentially? And so what you want to figure out is there a common ratio between numbers sequentially? So if you were to take from here to here and say 67.6 divided by 84.5, I think if you plug that into your calculator, you get about 0.8. So there's a ratio of 0.8, and you can find that you would get the same ratio here of 0.8. Okay, so you would then need to go backwards in time and say, well, then if it was multiplied or divided by 0.8 each time, then multiplied by 0.8 each time, then what would be the value here and here? And the reason we want to know bounce 0 is because that is the starting height, and we're going to need that to count for A. So if we go back, we'll find our calculator somewhere on this iPad. Not there. Not in education. Maybe it's productivity. It'd be nice if I knew where this calculator was. Here's a calculator. So we go back and we need to figure out 84.5 divided by 0.8. 84.5 divided by 0.8, and that gave us how high it was on the bounce before that, and then we divide that one by 0.8 again, and it should be about 132. Okay, so that means that this is about 132. So putting it all together, our equation is going to be y equals our starting value of 132, and we're going to multiply that by 0.8 every time we bounce it, and every time we bounce in this case is x. So that's how we find the equation, and that's how the different components of the equation template go into the exponential equation.